A system of two linear equations in two variables consists of two equations that can be represented in the form a 1 times x plus b 1 times y equals c1, a 2 times x plus b 2 times y equals c2, where x and y are variables, and a 1, b1, c1, a 2, b2, and c2 are constants. Each of these equations represents a straight line in the xy plane. If we rewrite the first equation in the slope-intercept form y equal m times x plus b, it will be as follows. Subtract a 1 times x from both sides. The equation yields b1 times y equals c1 minus a 1 times x. Now, if we divide both sides by b1, y equal negative a 1 over b1 times x plus c1 over b1. If you remember from the slope-intercept form, the coefficient of x, which is m, is the slope, and 0b is the y-intercept. Therefore, the slope of this equation is negative a 1 over b1, and the y-intercept is 0, c1 over b1. Let's graph this equation. First, we should place the x and y-intercept points on the xy plane. Then, we can graph the line. To find the y-intercept of a line, we substitute 0 for x in the equation. To find the x-intercept of a line, we substitute 0 for y in the equation. We know the y-intercept, 0, c1 over b1. We can find the x-intercept by substituting 0 for y in the equation. 0 equals negative 1 over b1 times x plus c1 over b1. If we subtract c1 over b1 from both sides, negative a 1 over b1 times x equals negative c1 over b1. If we multiply both sides by negative b1, the equation yields a 1 times x equals c1. If we divide both sides by a 1, x equals c1 over a 1. Now we can place the x and y intercepts on the xy plane. Then we can draw a straight line passing through these two lines. We can find the x and y intercepts of the second equation and draw the line similarly. There can be three types of relationships between the two lines. 1. Intersecting lines. The slopes of the two lines are different, and the lines will intersect exactly at one point. We can substitute one equation into the other to find the intersection point. The intersection point, x1, y1, is the solution of the two equations. 2. Parallel lines. If the slopes of the lines are the same, however, y-intercepts are different. These lines will be parallel and will not intersect each other. For the two equations in the form of a 1 times x plus b 1 times y equals c1, and a 2 times x plus b 2 times y equals c2. These lines are parallel if a 1 over a 2 equals b1 over b2, and this is not equal to c1 over c2. There is no solution for these two lines. 3. Congruent lines. For the two equations in the form of a 1 times x plus b 1 times y equals c1, and a 2 times x plus b 2 times y equals c2. These lines are congruent if a 1 over a 2 equals b1 over b2, and this is also equal to c1 over c2. There are infinite solutions for these two lines, as any point in any of these lines will also be present on the other line. How to solve systems of equations. There are three main methods to solve a system of linear equations: graphing, substitution, and elimination. 1. Graphing. Rewrite both equations in slope-intercept form, y equal m times x plus b. Graph each line on the same coordinate plane. Identify the intersection point, which is the solution. 2. Substitution. Solve one equation for one variable. Substitute that expression into the other equation. Solve for the remaining variable. substitute back to find the other variable. Example, consider the system 2x plus y equal 10 and x minus y equal 2. We can rewrite the second equation as y equal x minus 2. Now, if we substitute this for y in the first equation, 2x plus x minus 2 equals to 10. This yields 3x equals to 12. X equal 4. We can find the y value by substituting 4 for x in the second equation. 4 minus y equal 2. If we subtract 2 from both sides and add y, we can find y equal 2. The solution to the system is x equal 4 and y equal 2. 3. Elimination. Align the equations. Multiply one or both equations to make the coefficients of one variable opposite. Add or subtract the equations to eliminate one variable. Solve for the remaining variable. Substitute back to find the other variable. Example, consider the system 2x plus y equal 10 and x minus y equal 2. As you can see, the coefficient of y in the first equation is 1, and the coefficient of y in the second equation is -1. Therefore, if we add two equations, y's will be eliminated. Let's add two equations. 2x plus x minus y equal 10 plus 2. This yields 3x equals to 12. If we divide both sides by 3, x equal 4. We can find the y value by substituting 4 for x in the second equation. 4 minus y equal 2. If we subtract 2 from both sides and add y, we can find y equal 2. The solution to the system is x equal 4 and y equal 2. Note that this is one of the sample lectures from our comprehensive SAT Math Prep online course. The course was prepared by veteran SAT exam writers and 99th percentile SAT exam instructors. There are over 100 lectures, more than 500 practice questions, exercises, cheat sheets, tips, and tricks in our SAT Math Prep course. You can find the link to the full course in the description of this video. Unlike the usual SAT Prep courses, our comprehensive SAT Math Prep course prepares you for all the different types of questions you may see in the actual SAT exam. If any type of question is not in this program, it will not be in SAT exam.
We hope you liked our video. Please do not forget to hit like button and subscribe to be notified for new videos from us. We wish you happy learning.